3I Atlas, the interstellar object that is coming straight in line with the planets. It got even more strange, because whenever it was passing by Mars, NASA was ready to give us the clearest shot ever.
Something from beyond our solar system is cruising through our cosmic neighborhood right now, and the latest data from the James Webb Space Telescope have scientists scratching their heads in confusion. Here's the thing, 3I/ATLAS isn't playing by the rules we expected, and what we're discovering is raising more questions than answers. Stick around, because this interstellar visitor might just be the strangest thing we've seen yet. The unexpected discovery. When astronomers first spotted 3I/ATLAS on the 1st of July 2025 using the ATLAS survey telescope in Chile, they knew immediately that something unusual was happening. This wasn't just another chunk of space rock making its rounds through our solar system. The trajectory told a different story entirely. This object was traveling on a hyperbolic path, meaning it came from somewhere far beyond our sun's gravitational influence. What makes this discovery so remarkable is how bright it appeared from such an incredible distance. When scientists first observed it, 3I/ATLAS was sitting at about 4.5 times the distance between Earth and the Sun. At that range, most comets would be barely visible specks, yet this object was shining brilliantly in the darkness of space. This brightness suggested something truly massive, potentially around 20 kilometers in diameter if we're talking about a typical asteroid. The timing couldn't have been more perfect for science. Unlike the first interstellar visitor, 1I/Oumuamua, which zipped through our solar system in just 2 months back in 2017, we caught 3I/Atlas early enough to actually study it properly. Scientists immediately mobilized every available telescope to catch this cosmic wanderer. The excitement in the scientific community was palpable, but as more telescopes pointed at this mysterious visitor, the data started painting a picture that didn't quite match what anyone expected. When the James Webb Space Telescope turned its powerful infrared eye toward 3I/ATLAS on the 6th of August, 2025, astronomers were hoping for clear answers about this interstellar traveler. Instead, they got something that made them pause and look twice. The near-infrared spectrograph aboard Webb began capturing data that would fundamentally challenge our understanding of what interstellar comets should look like. The first thing that jumped out from Webb's observations was the chemical composition of the gas surrounding 3I/ATLAS. The telescope detected a massive cloud of carbon dioxide enveloping the comet, and when scientists calculated the numbers, they found something stunning. This object was losing about 70 kilograms of CO2 every single second. That's roughly the weight of an adult human being vaporizing into space every tick of the clock. Here's what makes this finding so peculiar. When Webb looked for water vapor, which is typically the dominant gas in comet atmospheres, it found surprisingly little. The upper limit for water loss was only about 4.5 kilograms per second. This means 3I/ATLAS has a carbon dioxide to water ratio that's completely off the charts compared to what we normally see in solar system comets. The data quality from Webb was exceptional, providing the clearest chemical fingerprint of an interstellar object we've ever obtained. The carbon dioxide mystery. Let's dive deeper into this carbon dioxide puzzle, because it's genuinely weird when you understand what it means. In our solar system, comets typically form in 2 main regions, the Kuiper Belt, beyond Neptune, and the even more distant Oort cloud. Both of these regions produce comets that are dominated by water ice. Carbon dioxide is usually a minor component, accounting for maybe a few percent of the gas at most. The fact that 3I/ATLAS is absolutely loaded with carbon dioxide tells us it probably didn't form in a region similar to our solar system's comet factories. Instead, it might have originated in an ultra-cold environment where carbon dioxide could freeze solid alongside water. We're talking about temperatures that would make the coldest regions of our solar system look positively balmy by comparison. What's really intriguing is what this tells us about the diversity of planetary systems across the galaxy. If 3I/ATLAS formed around another star, then that star system must have very different characteristics than ours. Some researchers have pointed out that this unusual composition could make 3I/ATLAS somewhat rare, even among interstellar objects. Or it suggests these CO2-rich comets might be more common than we thought. Now, here's where things get really head-scratching. Scientists have been struggling to pin down exactly how big 3I/ATLAS actually is, and the numbers don't want to cooperate with each other. Remember how I mentioned it appeared unusually bright when first discovered? That brightness suggested a large object, possibly 20 kilometers across, but as more data rolled in, that estimate started looking questionable. The problem is that brightness in astronomy can be deceiving. One of the most peculiar findings came when scientists analyzed the comet's movement. Most active comets experience what's called non-gravitational acceleration. Basically, the jets of gas shooting off the surface act like tiny rocket engines, slightly altering the comet's path. But observers tracking 3I/ATLAS noticed something strange. They couldn't detect any significant non-gravitational acceleration despite all that gas being released. This lack of rocket-like push suggests that 3I/ATLAS must be substantially more massive than the amount of gas being released. When you do the math, accounting for the 70 kilograms per second of carbon dioxide streaming off the surface, you end up with an estimate that the solid nucleus must be at least 5 kilometers in diameter, possibly much larger. If 3I/ATLAS really is 5 kilometers or larger, it's a completely different beast compared to previous interstellar visitors, the nickel anomaly. Just when you thought 3I/ATLAS couldn't get any weirder, astronomers detected something in its gas cloud that made them do a double take, an unusual abundance of nickel. Not just a little bit of nickel, but amounts that were surprisingly high compared to iron, which is typically more abundant in cosmic objects. This ratio flipped the script on what scientists expected to find. In most asteroids and comets from our solar system, iron vastly outnumbers nickel. But in 3I/ATLAS's coma, that cloud of gas and dust surrounding the nucleus, the nickel-to-iron ratio was unusually high. Now, before anyone jumps to conclusions, finding unusual metal ratios doesn't automatically mean anything artificial is going on. Space is full of chemical surprises, and different formation environments can produce wildly different elemental abundances. One possibility is that 3I/ATLAS contains material from a specific type of stellar explosion or cosmic event that concentrated nickel. The presence of these unusual metals also helps scientists understand the object's origins. The specific mix of elements can serve as a fingerprint of sorts, potentially pointing back to the type of star system where 3I/ATLAS was born. The James Webb Space Telescope wasn't working alone in studying 3I/ATLAS. A whole fleet of observatories jumped on this rare opportunity, each bringing its own unique capabilities to the table. The Hubble Space Telescope captured stunning images on the 21st of July, 2025, when the comet was about 277 million miles from Earth. Hubble's observations in visible light complemented Webb's infrared data beautifully. Down in Chile, the Gemini South Telescope caught something particularly exciting: the growth of 3I/ATLAS's tail. These observations revealed that the comet was becoming more active, releasing increasing amounts of dust and gas as solar heating intensified. The Very Large Telescope's MUSE instrument captured the first detailed optical spectrum, revealing that 3I/ATLAS has a distinctly reddish color. This coordinated observing campaign represents modern astronomy at its finest. By combining data from telescopes operating across different wavelengths, from ultraviolet to visible to infrared, scientists can piece together a much more complete picture than any single telescope could provide alone. Each observatory contributes a piece of the puzzle, and together they're revealing 3I/ATLAS's secrets layer by layer. Comparing to previous interstellar visitors, to really appreciate how strange 3I/ATLAS is, we need to look back at our previous encounters with interstellar objects. The first confirmed visitor from beyond our solar system was one I/Oumuamua, detected in October 2017, and it was bizarre in its own right, unusually elongated, tumbling through space, and showing mysterious acceleration that scientists still debate about today. Then came 2I/Borisov in August 2019, and it was refreshingly normal by comparison. Borisov looked and acted like a proper comet. It had a tail, it released gas and dust in expected ways, and its composition seemed similar to solar system comets. Now we have 3I/ATLAS, and it's throwing us curveballs again. Unlike Oumuamua, it's definitely showing comet-like activity, but unlike Borisov, its chemistry is completely off script with that carbon dioxide dominance. The size comparison is particularly striking. If current estimates are correct, 3I/ATLAS dwarfs both previous visitors by enormous margins. These three objects collectively tell us that interstellar space is filled with incredible diversity. We're essentially sampling the galaxy's comet and asteroid population one object at a time. The trajectory questions. Let's talk about where 3I/ATLAS came from and where it's headed, because even its path through space has raised some eyebrows. When astronomers calculated the comet's trajectory backward in time, they found it was coming from a region of space that doesn't have any obvious stellar neighborhood. In other words, there's no nearby star system we can point to and say, it probably came from there. This isn't entirely surprising. Objects can wander through interstellar space for millions or even billions of years. What's more interesting is the trajectory itself. Some scientists have noted that the path 3I/ATLAS is following through our solar system represents a statistical longshot. The exact angle of approach and timing combine to make this particular trajectory somewhat unusual. As 3I/ATLAS swings around the Sun, it will disappear from view for a while, passing too close to our star's glare for telescopes to observe it safely. The comet should reappear on the other side of the Sun by early December. After it passes and heads back out into the depths of space, 3I/ATLAS will eventually exit our solar system completely, returning to the vast darkness between stars. No discussion of unusual interstellar objects would be complete without mentioning Harvard astrophysicist Avi Loeb, who has become something of a controversial figure in this field. Loeb gained widespread attention for his willingness to seriously consider the possibility that Oumuamua might be artificial in nature. Now, he's turned his attention to 3I/ATLAS, and he's identified what he calls anomalies that deserve scientific scrutiny. Loeb has published several articles outlining his concerns about 3I/ATLAS. He points to the unusual size, the strange chemical composition with high nickel content, the lack of detectable non-gravitational acceleration despite significant outgassing, and the statistically unlikely trajectory. In his view, these anomalies, taken together, warrant keeping an open mind about alternative explanations. The astronomical community has mixed feelings about Loeb's approach. Many scientists appreciate his willingness to think outside the box, while others worry that jumping to exotic explanations before exhausting natural ones could mislead the public. What's undeniable is that Loeb's high profile has brought significant public attention to 3I/ATLAS, ensuring this interstellar visitor is being studied intensively, what the latest data tells us. So where does all this new data leave us? The picture emerging from the combined observations is of an object that's simultaneously familiar and strange. 3I/ATLAS is definitely behaving like a comet in many ways. It's releasing gas, developing a tail, and showing increased activity as it approaches the Sun. But the details are what make it fascinating. That carbon dioxide dominance keeps standing out as the comet's most distinctive feature. The ratio of CO2 to water is among the highest ever observed in any comet. If it really is 5 kilometers or more across, then it's carrying an enormous amount of material from wherever it formed. The presence of unusual metals like the elevated nickel levels adds another dimension to the puzzle. Looking at the complete dataset, most scientists feel confident that 3I/ATLAS is a natural object, an interstellar comet with unusual but not impossible properties. The chemistry, while surprising, can be explained by formation in extremely cold conditions. The anomalies that seemed so puzzling are starting to look more like interesting variations rather than inexplicable mysteries. While the mainstream scientific interpretation favors 3I/ATLAS being a natural comet, the unusual characteristics have sparked discussion about alternative scenarios. One theory suggests that 3I/ATLAS might be a fragment of a much larger object that broke apart at some point in its journey. The exposed interior material might explain some of the unusual chemical signatures. Another idea focuses on the possibility that 3I/ATLAS formed in a very different type of stellar environment than our Sun. Perhaps it originated around a red dwarf star, where cooler temperatures could produce comets with exotic compositions. Some researchers have proposed that 3I/ATLAS could be a planetary fragment, a piece of an actual planet ejected from its home system. The exotic end of the speculation spectrum includes the possibility of artificial origins. However, it's crucial to note that this remains highly speculative, and most scientists see no compelling evidence requiring an artificial explanation. What's healthy about all these discussions is that they push scientists to think creatively and not assume they understand everything. What this means for planetary science. Regardless of exactly what 3I/ATLAS turns out to be, it's already teaching us valuable lessons about planetary system formation and evolution. Every interstellar object we detect is like receiving a postcard from another solar system, giving us direct physical samples of what's happening elsewhere in the galaxy. The carbon dioxide richness tells us that planetary systems can produce comets with very different ice compositions than what we see in our own system. The size of 3I/ATLAS also provides important data about how large objects can be ejected from their home systems during chaotic formation phases. Scientists are using these observations to refine their models of how common interstellar objects might be. The chemical data is also informing our understanding of where different types of molecules can form in planetary systems. Eventually, after studying enough interstellar visitors, we'll be able to say something meaningful about typical versus unusual planetary systems. Either result would be scientifically valuable. Let's take a moment to appreciate the incredible technology making these discoveries possible. The James Webb Space Telescope, positioned about 1 million miles from Earth, observes the universe in infrared light, which is perfect for studying cold objects. Webb's near-infrared spectrograph can break down infrared light with incredible precision, allowing scientists to identify specific molecules. The coordination between multiple observatories has been equally impressive. Ground-based telescopes like Gemini South and the Very Large Telescope provided complementary data. The Atlas Survey Telescope that first discovered 3I/Atlas automatically scans the sky multiple times each night looking for moving objects. Even Mars orbiters observed 3I/ATLAS during its close approach to the red planet. Having these multiple viewpoints distributed through the solar system provides a kind of parallax effect that helps scientists triangulate properties more accurately. This represents modern astronomy at its finest, with international cooperation and modern technology working together. Public reaction and media coverage. The discovery of 3I/ATLAS has generated considerable public interest, though it hasn't quite reached the fever pitch of Oumuamua's media frenzy. The involvement of Avi Loeb and his speculation about possible anomalies has definitely added spice to the coverage. Media outlets love a good mystery, and questions about unusual objects make for compelling headlines. Social media has been buzzing with amateur astronomers sharing their own observations. While backyard telescopes can't compete with professional observatories, being able to spot this interstellar visitor with personal equipment creates a special connection. Educational institutions have seized on 3I/A/TLAS as a teaching opportunity, allowing students to follow along with actual, ongoing research. Online forums have hosted lengthy debates about the comet's properties and what they might mean. Even if not all the conclusions are correct, the fact that people are engaging deeply with scientific questions reflects genuine public interest in space science. Scientists have a clear roadmap for continued study of 3I/A/TLAS. The comet is currently passing through its perihelion and will be difficult to observe during late 2025 due to the sun's glare. But come early December, it should reappear, potentially more active than ever after its close solar encounter. The post-perihelion observations will be particularly interesting because comets often change dramatically after their closest approach to the sun. Webb will likely get another crack at observing 3I/A/TLAS in late 2025 or early 2026. Ground-based telescopes will continue monitoring as it recedes, helping scientists understand how the comet's activity winds down. Beyond 3I/A/TLAS, specifically, astronomers are now on high alert for the next interstellar visitor. Detection systems have improved dramatically, and facilities like ATLAS are better equipped than ever to catch these objects early. Some scientists have even proposed that if we detect an interstellar object early enough, we might actually send a spacecraft to intercept it. Stepping back from all the technical details, what does 3I/A/TLAS really mean for our understanding of the universe? At the most fundamental level, it's a reminder that space isn't empty. The regions between stars are filled with wandering objects, each carrying stories of their formation and the systems they came from. The diversity we're seeing among interstellar objects tells us that planetary systems across the galaxy produce an incredible variety of bodies. 3I/A/TLAS represents a democratization of galactic exploration. When objects from distant systems come to us, we can study them with our most advanced instruments. It's like the galaxy is sending us samples for analysis. The study of 3I/A/TLAS also showcases international scientific cooperation at its best. Telescopes from different countries, research teams from around the world, and data openly shared among scientists all contribute to our growing understanding. In a world often divided, the exploration of interstellar visitors reminds us of our common human curiosity. So, what have we learned about 3I/A/TLAS? This interstellar visitor has surprised us with its massive size, dominated by carbon dioxide rather than water, containing unusual amounts of nickel, and behaving in ways that challenge some of our assumptions about comets. While most scientists agree it's a natural object from another star system, its distinctive properties are teaching us that the galaxy produces comets in flavors we've barely begun to catalogue. The James Webb Space Telescope and other observatories have given us unprecedented insights into this cosmic wanderer, and there's more science to come as it continues its journey through our solar system and beyond. What do you think about 3I/A/TLAS and its unusual characteristics? Could this be a preview of even stranger interstellar objects we'll discover in the future? Drop your thoughts in the comments below, and don't forget to subscribe for more space discoveries.